Hello and welcome to another video. In this video we're going to be working on kth largest element in a stream. And in this one you have to design a class to find the kth largest element in a stream. Note that this is the kth largest element in sorted order, not the kth distinct. And you want to implement the class. And so in the class you want to initialize your object with k and the integers. And then you want to implement an add function that adds a value and returns the kth largest element. So let's just take a look at the examples. So here our original array is this, then we add a 3. So then the kth largest element, we're asked for the third largest, so we have 8, 4, 5, 3, 2, so we can even write those down. So we start off with 4, 5, and we can even do this in sorted order to make it easier. So we have 2, 4, 5, 8. And I guess what we can do actually, instead of this, we just have our array like this. And then we want to add a 3. So we're going to add a 3, and we're going to show this in sorted order. So it will basically look like this. So we just add a 3 in here, and oops, and that goes right there. And so our third largest element is a 4. And then we want to add a 5, so we add a 5. And the 5 is going to go, we can even do this, make it easier. So the 5 is going to go here, and then the third largest is a 5. Then we add a 10, so a 10 will go at the very end. And the third largest is 5. Then we want to add a 9, so a 9 will go here. And then the third largest is an 8. And finally we want to add a 4, and the 4 is going to be added over here, but the third largest will still be 8. So that's one way kind of like you could do it, like I was saying, is we can just make an array of elements, and every time we want to get the kth largest, we can sort it, and then we can just get the right index. So if we have an array of some numbers, like let's say we have this array, and let's say all of these are filled, so we have a 10 length array, we can just sort, and then if k is like 5 or something, then the index should be the length of the array minus k, I think. Yeah, so if k is 5, we want the element over here, which would be correct. And so you can basically just do that, and then you can put in an element sort, put in an element sort, put in an element sort. And the complexity of that one's going to be the number of adds you have, and then for every add, it will be the number of items you had. So it'll be something like n log n or something like this, you know, and which is going to be like n squared log n or something like that, depending on the size of your array and so on. So that's not ideal. So another way to, if you want the kth largest or k smallest element in something, is you can use a heap. And so a heap is going to, in a heap you can get like you can use a min heap or a max heap. But imagine if we have a heap and we only have 3 things. Like we want the, like let's do this example with a heap basically. And let's just say our heap can only hold 3 items. And so we're going to have a min heap. And the idea is the smallest item in, if k is 3, the smallest item in this heap will be the third largest element. So we're going to keep the biggest elements we can in here. Like anytime the element is bigger than the smallest element in here, we're going to pop that guy out and put in the guy here. And then it's basically, you can write it down as like, we want the smallest element out of the k biggest elements in the stream, right? So the heap is going to contain the k biggest elements in the stream, and the smallest element there will be the kth biggest element. So let's kind of walk through what I mean there. So in this case, k is 3, so we'll have the min heap. So we put in like 4, 5, 8, 2. So 4 is going to be the min, then we put in the 5, and we put in the 8. Then we put in a 2, and so actually we don't want to even put in the 2 because 2 is not smaller than 4, so we're going to leave our heap like this. Or alternatively, you can put in the 2, and then as soon as your heap is bigger than 3, just kick out the biggest guy. That also works. So we will put in the 2, then we'll just kick out the smallest guy. So this is like our starting heap. Then we put in a 3. So 3 is our smallest, and our heap is too big, so we kick out our smallest guy. So our kth largest element is just always going to be the min value in the heap, which will be 4. Then we put in a 5. And then our smallest value is now the 4, so we'll kick that out. So our kth largest element is 5. then we put in a 10. So when we put in the 10, the 5 will get kicked out. So I'll just put it in like this. And then the smallest element is 5. Then we put in the 9. When we put in the 9, the 5 will get kicked out. And our smallest element is over here. So we'll get 8. And then we put in the 4, and then the 4 gets kicked out, and smallest element is an 8. So that's the basic idea, is we make a heap that's k size. And then anytime our heap is greater than k, kick out smallest guy. And then all we have to do is just return the smallest value in our heap, and that's going to be the same thing that I wrote. So that's what we're going to do. So that's the better way to do it. And then that way, every time we do an add, that's log n. So then our solution goes from like n squared log n to n log n roughly, which is going to be better. You can also, I guess, yeah, so you can do one of two things. You can either have the heap of size k, like I was saying, right? And you add an element, you kick out the smallest guy, or you can just check. You can just check, like, if we're already size k, if our element shouldn't be in here, we don't even have to add it. So either one is fine. I guess we'll do that approach. So if our element shouldn't be in here, we just won't even add it. And if we do add it, then we'll kick. I think either one's fine. Okay. So we're gonna first make a heap. So we can just say like heap, and this will be a priority queue. Yeah, I think I'll start coding in Java without the autocomplete too. It's a little bit hard because there's like so many functions and hard to get all the names right. We'll see how it goes. So priority queue, and so this is going to be an integer heap. Call it heap, and then we need to keep track of this k number for later. So k, do our initialization here. And because it's a min heap, that's like the default implementation, so we don't have to give it any kind of comparison function or anything. And k equals k. Okay, so we'll go through every number in nums. So for int num in nums. So if our heap is already full, so heap size, well, let's just say when we will put in items. So if heap size is less than k, or heap poll, I think is the first guy, is less than the item we're putting in. So if we have space, or the smallest element in the heap is big, it's smaller than the item we're putting in, let's put in this item, and then pop if we need to. So we're gonna say heap add. And then if we did add something, then we just check if our heap is now, yeah, so if heap size is now greater than k, then we need to pop. And this is not poll, this is peak, I think, to get the first item. Okay, so basically if our heap has space, we put it in, or if our item is bigger than the smallest item in the heap, we put it in. And then if our heap grows too big, then we pop. So that should initialize our heap. And then here, we have to basically do the same thing. So we can just copy this. In fact, you can even, yeah, we can even use the add function. Maybe that's a little bit cleaner. So we can use the add function instead of this. So that'll be a little bit cleaner. So what we can do is we can say this. So if heap size, all that is fine. And it's guaranteed also that like you'll have items in the heap. You're not just going to be, or you'll have enough items. So if you want like the 5th smallest item, you're going to have 5 items when you call this function. Okay, so anyway, so if heap size, this is all fine, except it's going to be value instead of num. And then let's clean this up a bit. Okay. And so we just need to return heap peak. Okay, and now we're gonna use this add function in here. So we can just say heap, or we can just say add, and then we're gonna add the value. I don't think you need to do this, we'll see. So essentially, yeah, so basically for every single value in the array, we're gonna add, and we don't really care. Like, it's gonna give us the smallest item in the heap, but we don't really care about it, so we'll just do an add. Now it's a little bit cleaner. Oh yeah, let's see how it goes. Okay, let's see what errors we get. So I guess we need this. Dot add val. Oh, val num. So I wonder if we did need this or not. Maybe we do. No, you don't. Okay. Okay, there we go. So yeah, either way works. And these kinds of solutions, like, it depends. I think when I wrote this earlier, when I just added and then popped and I didn't have all these checks, it was faster. So, but it's not like super concerning because these things are pretty fast, so it's not like a big deal. Yeah. Okay. And so I can get rid of this. So we can say the time here. So basically, let's look at our constraints and stuff. So the time is going to be based on, first of all, like the length of this array. So the length of this array will be, every item will be added, I guess. Like, worst case scenario, every item is added. But then the heap can only be size k. So it'll be something like length of the array. Let's call that like n log k, because a push or a pop is the log of the size of the heap, which is not going to be bigger than k. And then n is going to be like the length of this array plus the number of adds we're going to call, something like that. So maybe you could say like the length of the initial array plus the number of adds or something, or just n log k is fine as well, I think. And then the space. So we're using a heap, but our heap is size k now, so that's just O of k. Where the original solution was create a whole array of items, never delete anything, and then keep sorting, which is going to be worse. You could, in that initial array of items, you could actually use like a deck, but then you're still going to have to keep sorting. So like instead of like adding a number, like I was saying, like we have a bunch of numbers, add a number. Like let's say this is our numbers. Like let's say it's these. Instead of just keep adding a number, we can say like if we want the third biggest, and we already have those, like yes, we'll sort every time, but we don't need to store this whole thing. So you could use a queue and just get rid of like everything below the, basically everything below and above the top three, I think. Actually, no, you can't get rid of everything above the top three, but you can get rid of everything below the top three. Yeah, something like that. Because like, yeah, because like let's say this is like 987, we add a 10. Yeah, like if you add this, you know you can get rid of this for sure, but like 10 might become the third smallest element or something if we add like 11 or 12. But like these will never be the smallest element because we're not deleting anything. So that's another way you could do it. It'll be a little bit more efficient, but it'll still be worse. Basically, every time you'll do like an n log k sort, and then your deck will be k length. So that's another way to do it. But it's gonna be worse than this. This is the ideal solution. And yeah, it's gonna be all for this one. Hopefully you liked it. And if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.